Google DeepMind is always up to something new. In this paper, they have come up with yet another way to maybe circumvent fine tuning. Let me explain. In context learning is one of the hallmark of large language models. In context learning, or ICL in short, is a machine learning method that involves training a model to perform a task using examples given within a prompt. Unlike other machine learning methods, ICL does not require any parameter updates, and the model is able to learn and perform a task in a single shot. This method is particularly useful for LLMs and has been applied in various NLP tasks such as sentiment analysis, question answering, and text generation. ICL is also beneficial in decision support system and various other problem solving techniques when it comes to machine learning. Now, coming back to this paper, in this paper, these researchers from Google DeepMind have investigated many shot in context learning or many shot ICL, and they have found out significant gains in performance when going from few shot to many shot in a wide range of tasks, including translation, summarization, planning, reward modeling, mathematical problem solving, scientific question answering, and algorithmic reasoning. To overcome the challenges of obtaining a large number of high quality human written rationale for many short learning, they have introduced two new in context learning regimes. First, reinforced ICL, and second one is unsupervised ICL, which I will try to explain later in the video. But for both of these, they have found out that for problem solving domains where human generated rationales are expensive to obtain, reinforced and unsupervised ICL can obtain strong performance when compared to simple ICL with human data. They have also concluded that with a set of analysis experiments showing that many short learning can overcome pre-training biases that allows learning non-natural language tasks typically difficult for LLMs with few short learning, and they have also explored negative log likelihood trends with respect to context length in the many short settings. Now, for example, if you look at this diagram, this is many short versus few short in context learning. Before we delve into this diagram more, let me also try to clarify what exactly is meant by short here, because I have used this word single shot, few shot, many shot. So what exactly is this shot? In machine learning, short refers to the number of labeled examples for each new class. We have few short learning, which means that limited number of labeled examples for each new class. We have single short learning or one shot learning, which means only one labeled example for each new class. And we have zero shot learning, which means no labeled data available for the new class of the data. So that is what short means here. Now coming back to this photo, this is a diagram where it is showing us many short versus few short in context learning across several tasks, and the tasks are summarization, GPQA, translation, and you can see in the horizontal line that all the tasks. Many short learning shows consistent performance gains over few short ICL, as you can see in this diagram. This gain is especially dramatic for difficult non-natural language tasks like sequential parity prediction and linear classification. Number of best performing shots for many short ICL are shown inside the bar for each task. For few short ICL, they have either used typical number of shots used in a benchmark. For example, if you look at the diagram, 4 shot for math, or the longest prompt among the ones they have tested with less than GPT-3 context length of 2048 tokens. Reasoning oriented tasks, namely math, GSM8K, BPH, and GPQA, use human generated chain of thought rationales. For translation, they have reported performance Florus empty result on English to Kurdish. Summarization uses Excel sum, and math corresponds to the Math 500 test set. And sentiment analysis results are reported with semantically unrelated tasks. So ICL with a large number of shots, for example, 100 or more, can potentially make LLMs more versatile, adaptable, and ultimately more useful. And that is the whole crux of this matter as they investigate how scaling the number of in-context examples or shots affects LLM performance across diverse downstream tasks. So if you look at from another angle, as I was saying, so they have two approaches: reinforced ICL that involves providing a chain of thought rationale with problem solution pairs, and they have unsupervised ICL that only um, provides the problems without solutions. It is only useful when large scale label data is unavailable or too costly. So basically, the idea here is to reduce all the reliance on expensive and time consuming human label data, and it will make more self sustained training or fine tuning on the part of LLMs. That is the whole idea behind it. But so I believe it's a very intuitive approach, and we might see it in action in a lot of models and fine tuning techniques in the future. I will drop the link to this paper in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.